Hello everyone, I am Stikta Kakkad and this is my channel AccelerateAICareers. Today we are going to solve a very interesting LeetCode problem, LeetCode 69, square root of x. It has been asked in last 6 to 12 months for several companies interview rounds such as Amazon, Microsoft, Google. It's on the easiest side, so it's not a tougher one as a breather because we did a hard level problem yesterday. So let's look at the question here. It says that you have been given a non-negative integer x. You have to return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use any built-in exponent function or whatsoever, any operator in Python. For example, you cannot use power of x comma 0.5 in C++ or x multiplied by 0.5 in Python. So do note that you have to return the square root of x even though you might find it in decimal. You have to round it down to the nearest integer. So that's the most important aspect of this question. So let's look at some examples here. You have been given x equal to 4. The output for it would be 2 since square root of 4 is 2 and it's an integer itself. But say suppose like example 2 you have been given x equals to 8. Now square root of 8 is not a direct integer. It's somewhere around 2.82. But you have to round it off to the nearest down integer, which would be 2 again. So your output is 2 here. So I hope you understand the crux of the question. I'll explain you 2-3 approaches to solve this question and then we'll code it using the best approach. So let's dig deeper into it. Now the brute force approach for solving this question would be, say suppose you have been given x equal to 7. In that case, to search for the square root of 7 or the nearest integer to the square root of 7, we might choose to go from 0 to 7 and run the loop and then check if square of 0 is actually 7. Okay. Then we check square of is actually 7. Then we check square of 2 is actually 7 and so on. Okay. So like 0 square is 0. So it's of course less than 7. 1 square is 1 less than 7. 2 square is 4. So it's less than 7. I'll just write it here. So 4 is less than 7 here. Okay. 3 square is 9, which is greater than 7. And we want an integer here which is rounded down to the nearest integer square root. So 3 cannot be the square root since its square is greater than 7, right? So 2 square is 4, which is less than 7, hence the answer is 2. If you go by this approach, you would say that the time complexity is O of n because I am running the entire loop from 0 to 7. But that's not true because you will stop eventually a lot before than reaching 7. I would say precisely you would stop at root of 7 or close to root of 7, right? So your time complexity is actually O of root 7, which is not that bad, right? When we talk about brute force approach. But could it be better? So I will propose an O of log n solution now after this approach, which is better than this one. But when you would ask me, Snigdha, how do you know that O of root n solution is not that great when compared to O of log n solution? So let me show it to you with an example. Say suppose my n is 1 million. In that case, if my n is 1 million, then root n comes out to be 1000, right? But log n comes out to be somewhere around approximately 20. So do you notice the difference? So as and when your n increases, if you take the time complexity and then compare, then your log n time complexity is way less when compared to the time complexity of O of root n. Hence, we should not go by brute force solution rather than look at the other solution I'm going to propose now, which is not something new. It's a binary search solution. So let's see how we can solve this question using binary search. To solve this question using binary search, I'll again take my range from 0 to 7, of course, because I have to consider all non-negative integers. But instead of looking for squares of all, I will find the midpoint. The midpoint would be 0 plus 7 by 2, right? Somewhat in between the left and right pointers. And I will check if m square is less than 7. If m square is less than 7, in that case, I will update my right pointer because I know that my square root of 7 would either be m or greater than 7 in that case. So my left pointer will become m plus 1. And I will save m as a candidate for result because it could be my result, right? But what if there's another scenario that m square is greater than 7? In that case, I know that any value greater than m will also have its square greater than 7. So it's of no use to me. Hence, I will reduce the right pointer. And my right pointer will become m minus 1 because I have to find m square which is less than 7 and closer to square root of 7, right? But there could be a third scenario in case if I have been given an integer whose integer square root exists. In that case, m square could be equal to 7. So if m square is equal to 7, in that scenario, I will just return the result m because I have found the square root m. Since we always divide the range in two parts and just process one part, that's called binary search algorithm, and the time complexity for that would be O of log n with base 2. So that's the entire approach, entire crux of the approach we're going to use to solve this question. So let's start coding it. So I will first initialize my left and right pointers. My left pointer will be initialized at 0. My right pointer will be initialized at x. And I'll also initialize my result variable. I can initialize it with anything. I'm initializing it with 0 here. Now I will run my binary search loop, which would be while L is less than equal to R. Our pointer should not cross. That is, we should not run the entire loop. Until then, we can run the loop. And then I'll find M. Now my midpoint can be found by left plus right by 2. But in that case, my solution might overflow. So that you should know about. And then we can write that equation in a separate way. And that's how we can avoid it from overflowing. So instead of writing left plus right by 2, I'm writing left plus r minus l by 2. It results in the same equation, but this doesn't result in answer overflowing, okay? And then I check if m square is greater than x. If m square is greater than x, then what? In that case, I update my right pointer to m minus 1. As if m square is less than x. If it is less than x, in that case, I have to update my left pointer to m plus 1. And I also have to update my result to m because m could be a candidate for my result. Otherwise, which would be the case that m square is equal to x and you have the exact value, in that case, you just return m because you have found the square root. Now, when you are outside the loop and you have run the entire loop, then you can return your result. So that's the entire code. So let me run it and see if it works. So it's accepted. Let's submit. The solution is submitted. It's accepted. Now I'll just summarize the approach for you. So we'll initialized our left and right pointers by 0 and x, and we initialize the result variable as 0. Now I'll run the entire loop, and how the entire loop is run is while L is less than or equal to R. And then I take the midpoint. Now to avoid the solution from overflowing, I have calculated the midpoint using this formula, left plus R minus L by 2. Now I check if m square is greater than x. In that case, anything above m will also have its square greater than x. So I update my right pointer accordingly to m minus 1 because my solution will lie between 0 to m minus 1. As if m square is less than x, then I will update my left pointer to m plus 1 because my solution will lie somewhere between m to last value, that is x. And I also update my result as m because m could be a candidate, okay? Else, I found the exact square root, that is m square equal to x. In that case, I just return m. And outside the loop, I can return the result. So that's my entire solution. If you have any questions, any doubts, I ask them in the comments. I would be happy to delve deeper into it. Now, if you like my way of solving problems, then subscribe to my channel to get your daily notifications for your daily LeetCode challenge. Thank you.